The complex number I, or the imaginary number I, is defined as the square root of -1. And with that definition comes a number of consequences, and I'll write those down here. So you can imagine that I is just equal to I. That's a silly thing to say, but it's true. And I squared is equal to I times I. Because it's the square root of -1, any square root times itself is just the radicand. So I times I is -1. Okay, well that's interesting. I cubed is simply I times I squared, which means this becomes -1 times I, or in other words, -I. And I to the fourth equals I squared times I squared, which means -1 times -1, which is 1. So this right here gives you an idea of some of the properties of I that we can use in this problem. So I'm just going to write them down here. I equals I squared equals -1, I cubed equals -I, and I to the fourth equals 1. Well, if you were to follow that same exercise over here in this column, you would see that all of these things follow the exact same pattern, right? I to the fifth is just I times I to the fourth. I to the fourth is 1, so this becomes I. And likewise, -1, -I, and 1 if you go through all the algebra. Now, what this problem is asking you to do is to prove that you know this thing that I just went through. Prove that you understand it by finding some way to add these terms up so that it makes -1 plus I. There are a lot of ways to make this work. I'll just give you an example. I could do I squared plus I. Okay, I would select those two terms and mark these boxes, and there we go. The sum of these things will be -1 plus I. Now, the only reason that's not going to work is because in this particular problem, it says do at least 4 of them. Okay, so you'll have to be a little more creative than I was right here in finding a sum of these that equals -1 plus I. But I think with what's written down on the screen here, you have all the basics that you need. So enjoy.